am recording them for you in case you missed something and you wanted to rewatch it, or in case you were absent and you wanted to see what we did in class today, so that you can continue with our learning. So we talked about composite functions, and composite functions are something that should not be new to you. It is something that you should have learned in Algebra 2 Trig or the honors. You should have learned in pre-calc or honors, and so we're going to review some of those pieces today. So as a reminder, a composite function is if the functions f and g are functions then the composite of f and g. Okay, so this can be written two different ways. You can either write f little circle for of g of x, or you could write f parenthesis of g of x. And those two things mean the same thing, okay? That is the composite function of f and g. And then I'm going to say where in this particular case, f of x is the outside function, and g of x is inside of f of x. So we call g of x the inside function. Again, f could be inside of g, or you could have h's or j's or k's or LMNOP's, but based on this setup, okay, the function that is on the outside in this particular case would be f if it's listed first in this notation, or f again if it's listed first in that notation. And the inside function would be g, the second listed function, or g, again, that second listed function. And so we're going to go through today and we're just going to review some of these concepts. We're going to put functions together and we're going to pull functions apart. So it says given that f of x equals x squared minus 3x and g of x equals the square root of 9 minus x, complete the following and simplify your answer. So I have f of g of x. That tells me that I need to put the g function into the f function, okay? So here's my g function. What that means is that I'm going to put that square root of 9 minus x in place of the x's for my f function, okay? So I'm going to rewrite my f function. That's my outside function. I'm just creating a skeleton because what I'm going to do is I'm going to replace the x with the g function. I'm going to put the g function inside of the f function. So every place there was an x, I'm going to write square root of 9 minus x. Okay? And then I said to go ahead and clean this up. Well, if I square a square root, I'm just left with what was underneath the square root. And if I multiply a number times the square root, I just write it as a coefficient, right? 3 times the square root of 9 minus x. And that's it. I cannot clean this up any further. Okay? And this is equal to f of g of x. All right, I'm going to do number 3 with you. And number 3 is written in that other notation. And notice there's no g with this. Okay? It says f of x. And what that means is I'm going to take the f function and I'm going to put it inside of itself. Inception. Okay? I don't know if you guys watched that movie, Inception, with Leonardo DiCaprio, but that's the idea here. Okay? This is equal to. So again, I'm going to build this framework. The framework for the f function is x squared minus 3 times x. And in place of the x, I'm going to write the f function inside of itself. And the f function is x squared minus 3x. So again, every place there's an x, I'm replacing that x with a function. Whew. And if I were to multiply this whole thing out, so if I squared this, I would get x to the 4th minus 6x cubed plus 9x squared. And then if I, thanks. Sorry guys. And then if I were to distribute that negative 3, 3x squared and then a plus 9x. Sorry, this should have a squared with it. Okay. So if I finalize this, I get x to the 4th minus 6x cubed plus 6x squared plus 9x. And all of this is equal to f of x. Okay, so let's talk about how to evaluate these functions at a particular x value. Okay, so when I go to evaluate, I always want to evaluate the inside function first. Sorry, I have no idea what's happening with this marker today. I'm going to evaluate the inside function first. What that means is I'm first going to evaluate what g of negative 7 is. And remember, my g function was square root of 9 minus x. I'm just going to replace that x with negative 7. And that gives me square root of 16, which is equal to 4. So g of negative 7 equals 4. And now I'm going to take that and I'm going to evaluate the f function at my answer. So now I'm going to evaluate f of 4. And again, that f function was x squared, so 4 squared, minus 3x, so minus 3 times 4. And that's 16 minus 12, which also happens to be 4. So overall, by some coincidence, f of g of negative 7 is 4. Okay? All right, now, here comes the big deal. So, that was review. The review was, hey, if I have this composite function, I'm going to put one function inside of the other. But what we need to be able to do in calculus is actually pull those composite functions apart. So this is given h of x, determine two functions. Okay, we're going to determine the f of x function and the g of x function such that h of x is equal to f of g of x. And I just want to make it known as a reminder that f is the outside and g is the inside, and that's based on how we define composite functions up top. G is inside of f, and so that's all I'm going to do here. And I actually think that it's easier to come up with that inside function first. I'm going to go ahead and write outside and inside. The outside we'll call f of x, the inside we'll call g of x, but I still think it's easier to come up with that g of x, that inside function first. So I'm using my highlighters to help me with this, okay? So it looks like this 2x plus 1 is inside of parentheses, okay? And so because that g of x, or that 2x plus 1, is inside of parentheses, I'm going to call that my inside function. And it looks to me like that 2x plus 1 is inside of parentheses, or replacing. This is what's tricky for some people. Sorry, my phone is ringing and I'm just going to have to answer it later. This is what's tricky for people. That 2x plus 1 is inside of x squared. My outside function is x squared. That 2x plus 1 is replacing an x to create that x squared. And you can always go back, sorry about that phone, you can always go back and double check and say, does this make sense? Does it make sense that 2x plus 1 would go inside of x squared to create this h of x function? And the answer is yes. All right, let's try another one. So if h of x equals cosine of 4x. So again, I'm going to go ahead and say that I need my outside function, which is f of x. I need my inside function, which is g of x. And I'm always looking for what's inside of something else. Well, again, it looks like this 4x is inside parentheses, so the 4x would be my inside function, or my g of x function. Big sub e. Okay? and that is inside of my cosine function. So my outside function must be cosine of x. And remember, the inside function is always going to replace an x. Okay? I'm going to do 11. So remember, I could rewrite this as the sine of x being squared. And I'm going to take it like that, okay? I'm going to take it as the sine of x being squared. So again, I have an outside function and an inside function. We define the outside function as being f, the inside function as being g. And to me, again, I look for the parentheses. What's inside those parentheses? The sine function is inside of those parentheses. So it looks like sine of x is my inside function, and that would be inside of x squared. That inside function is replacing an x. So when I write my outside function, I'm writing x squared. All right, let's flip this over on the back. I want to run through a table and graph problem. So let's take a look at 18. And in 18, I have f times g prime of 0. And remember that this right here is a product. So this is not a chain rule. I'm sorry, this is not a composite function. I'm ahead of myself. This is not a composite function. This is a product. So when I go to set this up, I need to use the product rule, okay? Versus if I look at something like 20, comparing that to 20, I have f of g of -4. So we have to be able to spot the difference between something like 18, a product. There are no parentheses between f and g. It's just fg. That's a product. And something like 20, where it says f parenthesis g. So that's f of g. Okay? And so I'm going to go ahead and do number 20. All right? That's what I did in class with something like 20. Again, I need to evaluate that inside function first. G of -4. I'm going to look up at my table and graph, and it looks like the table is my g function, and g of -4 gives me an output of 1. And then I'm going to go back and I'm going to evaluate my f function at this answer. So I'm going to say, okay, now I have to evaluate f of 1. Right, whatever my answer is becomes the input for my outside function. Okay, so now I gotta go to my graph, and f of 1 is -4. Who makes up these problems? All right, I get -4. And so f of g of -4 happens to also be -4. So that's what you would do for 21 and 22. Okay, again, this was just a review in case you wanted to rewatch or in case you were absent. Again, I apologize for the phone ringing in the background, and let me know if you have questions.